Hi, everybody. This is Mitch Tanenbaum and Ray Hutchins. Today, we're going to talk about secure software development processes. It's called two different names depending on who you're talking about. It's either a secure software development lifecycle or more recently, a secure software development framework. We'll talk about the difference between those two. But both of those are about having your software be more secure. In the days of hacking, that's what we've got to deal with right now. We've got to deal with the fact that people use weaknesses in software. And we see this in commercial software, right? We see that even big companies like Oracle or Microsoft, they're releasing patches all the time. Why is that? Because their software, much of which was built years and years ago, doesn't have secure software development principles built into it. And so there are bugs in it. So that's what we're going to talk about today. Let me see how quickly I can do it. So the state of the software supply chain, it says that even applications, remember when your development team builds an application, they're not developing everything from scratch. They are using modules that they downloaded from the internet, they bought from a third party, came from a previous project, and those all need to be part of the secure software development process. But we look at some of the very recent software supply chain attacks that have had big effects on many companies. You remember the Microsoft Exchange attack that affected the government, the Kaseya attack, which affected thousands of companies, Log4j, which probably is in the tens of thousands, SolarWinds, which affected the government, as well as private industry, big companies, Fortune 500, as well as tiny little companies. And what the reports are is that the software supply chain attacks have grown dramatically over the last year. And that's going to keep going. Why do they do that? Because if they do an attack of the supply chain, let's say they attack Kaseya, for example, and that affected 1,000 of their managed service provider partners, and each one of those managed service provider partners had 100 customers, well, they now have a target of opportunity of 100,000 networks. There's no way other than supply chain that you can go do that. So as a result of that, we really need to ramp up that. So here's kind of what we're going to talk about. We're going to start with the executive order that the president released, what NIST came up with as a result of that, the difference between the SSDL and SSDF, OWASP, which was an open source tool for helping you work on some problems. Microsoft has really gone out of their way. I'll talk about why that is, and other resources and materials that we're going to provide you. So let's talk about the.
Oh, Mitch, let me start. Let me interject something real quick. This training is not just designed for technical people and the people who are developing the software. This training that we're providing you, this is, yes, for them, that's for sure, but it's for the executives. One of the big reasons that the entire software supply chain of the world is in such bad shape with respect to this is that the executives don't understand the development process and don't have a tight enough grip or tight enough management process on top of the development process. They turn it over to other IT people, which are doing the best job they can and whatnot. But this has got to come from a top-down risk management perspective in terms of how much risk is the company willing to take, and having applications that the company is using that are not protected against attack, it should be unacceptable to all management. We just cannot do it. Yes, I know we've done it in the past. Yes, I know we didn't have to worry about it in the past because we didn't understand it, but that doesn't work in today's environment. Today, you have to take it seriously. And you see, getting an executive order, which Mitch is going to talk about in a second here, from the president's office. If you've got the president of the United States, by the way, if you'll remember in recent presidential elections, when you're hearing the presidential debates, were they ever talking about cybersecurity? Did they ever debate the issues? Ever? Republicans, Democrats, anybody, ever? No, never. But yet now this stuff is coming down from the top because they recognize this is a national security threat. So I'm saying to all executives, pay close attention, even more so than the IT people. The IT people know what OWASP is and the Microsoft stuff is. They can, but the executives don't. Wrap your mind around this and get it so you can ask the right questions. Thank you.
So, and for the executives, the single biggest complaint that I get from IT folks is management won't give us the time or the budget to do it right. They just, I used to say this, I don't say it anymore. There's never time to do it right, but there's always time to do it again. And that's the strategy, and we see this in a bunch of the
Say that
.com.
again, Mitch. Would you say that again? That's a very important line that people ought to be embroidering on pillows right now.
There's never time to do it right, but there's always time to do it again.
Okay.
So the challenge is, right, and we see this in the big .coms. Well, we want to fail fast. Well, there's failing and there's failing, right? The failing is when you get hacked. That's failing. That's probably not a great failure mode. And this also applies not only to software that you're building, because many companies don't build their own software, but it applies to software that you're buying. And we see, for example, Kaseya is software you buy. Microsoft Exchange is software you buy. SolarWinds is software you buy. Those are three big attacks that happened in the last year or so. So this affects both software that you buy and software that you make. So that's another important distinction. The executive order legally only applies to executive branch agencies and their vendors. So if you're not selling software to the government, or you're not selling software, this is important, to companies who sell to the government, then you are not covered by, legally, you're not covered by the executive order. But the executive order is, and I've seen some of these executive orders in the past that are like 2 paragraphs. This thing is like 40 pages. There's an amazing amount of action items, and I'll give you some links on the next slide where you can go off and look at where I kind of took the executive order apart and broke down some of the actions. But one of the things that came out of that is NIST was told that they need to go come up with this secure software development framework. That is in the executive order, and they have done that, and they've actually had 2 releases of it. But as a business, whether you sell to the government or you don't sell to the government, this is just best practices. There's nothing in this executive order that you shouldn't be doing anyway, whether you sell to the government or you don't sell to the government.
The major component of that executive order, as I read it, was that section 4, which was the supply chain, which is about what we're talking about right here. That was kind of like, in that entire executive order, the premier piece of content in there. That's how important it is to the country to address this issue.
So what the difference is between the software development lifecycle, which is kind of older, been around for probably 20 years now, and the secure software development framework, is the formality of it. The secure software development lifecycle says, hey, you ought to go test stuff, and you ought to have some security practices. But there really wasn't a framework. There really wasn't a template from which you operate. Whereas the SSDF that NIST has created is really a much more structured tool. Now, there are secure software development practice documents, BSA, that comes out of England, OWASP, which is an international effort, open source effort, and source code. These are tools which should be part of your secure software development lifecycle and secure software development framework, but they're not sufficient by themselves. One of the things that's really important in the framework is talking about is you got to have a structure. You got to train people, you got to manage people, and you got to manage to these processes. Gene Kim, who is the founder of the DevSecOps movement, said that you need to be dealing with security issues in every single iteration of your software development process, whether it's agile, waterfall, whatever it is. Every single iteration needs to spend some part of your time in that effort to go off and improve the security of your product. That historically is not done. Does it work? Let's ship it. That's the mantra that's always been the case.
Remember, this is coming down from NIST, the National Institute of Standards in the federal government. This is the organization that uses their budget and all their experts to create best practices for all kinds of industry stuff that's going on in the United States. And this serves as a model for other nations around the world. NIST has released the NIST Cybersecurity Framework, the NIST Privacy Framework, and now the NIST Secure Software Development Framework. These are very important national best practice efforts that's being led by the federal government, and then everyone else is lining up behind these frameworks. The Department of Defense, their whole program is based upon the NIST work. They've done some stuff on their own, but yet it's based on this. You've got our major allies globally are lining up behind our standards. That's how carefully they've been done and worked out. So this is important stuff. Again, I'm talking to management here, okay? And so I'm saying, you got to know about this. You got to understand it, because your entire business operations are built on top of an IT infrastructure that is inherently insecure from the get-go. But you have got responsibilities for protecting data and intellectual property and other things. How do you do it? How do you do it? You follow the frameworks. Follow the frameworks. You don't have to reinvent the wheel, but you got to put that wheel on the car to drive it.
So if we look at the tools like OWASP and BSA, they really start at the third bullet on this screen. So let's back up to the first bullet, because that's one of the places where we don't see people spending a lot of effort, and that's preparing the organization. That means training the people, getting the tools, getting the policies in place, making sure that the marketing guys and the sales guys. I mean, how many times you heard the story? I've heard it a lot from IT guys. The sales guy says, they came over to me and said, if we don't get this thing out today, we're going to lose this customer. And my answer to that is, and if you get it out today and it's buggy, or it leaks their data, then what happens to that customer? You can lose that customer. Not only you lose the customer, you're going to wind up with a lawsuit. So preparing the organization is where you start, and that takes effort. And remember, this applies whether or not you are building software. Even if all you're doing is just buying software, it still applies. So then the next thing, and this is where we saw some of the attacks, like the Kaseya attack, you got to protect the software. If you are distributing software of any kind to your customer, whether it's software that you've built or software that you've purchased and are redistributing, you got to make sure that that supply chain from you to your customer, from your supplier to you, from you to your customer, that supply chain is secure, that it can't be compromised by a bad guy. We've seen this time and time. I mean, I can remember back in 2011, 2013. I mean, it goes back a long time. This is not new, these supply chain attacks. What's new is the bad guys have figured out, hey, this is easy because people's supply chain sucks. And so we can do this really easily and cause that to, spread out across all of their customer base. And guess what? Who gets to take the blame for that? No one is blaming, whoever Kaseya's supplier was. They don't care about that. Whoever Microsoft, they don't care. It's, I bought it from you, and I'm going to blame you. So that's protecting the supply chain. The next one is producing well-secured software. That's the software development process itself. Whether it's your software development process or your vendor's software development process, you need to be asking your vendors, tell me about your secure software development framework. And if they go, then maybe you need to go look at a different vendor, or at a minimum, you need to go look at your contract and see whether you can sue them when they get hacked, because they're going to get hacked. Right.
One of our main, we do many things as cybersecurity guys. But one of the main things is helping a client. A client's coming in, and a client, in order to operate their business, they need a lot of different technical tools, i.e. software applications that they have to use that other people have produced. Okay. And so they ask us, and they always have a big choice in front of themselves. They're trying to evaluate, well, which one's best? This one's cheaper. This one's more expensive. What's all the feature sets? What's our requirements? Blah, blah, blah. All this stuff that goes into making a decision, right? Or should go into making that decision. Then we get down to all the time, and this is what we bring up. Well, okay, how much of your sensitive data are you sharing with this application? What are you putting in there? We do a lot of business in the mortgage lending space. So mortgage lenders are uploading all kinds of sensitive financial documents into these applications and whatnot.
And it's really their customers who are uploading it, right?
It's their customers are uploading it via the mortgage lender. Yeah. But ultimately, the mortgage lender is responsible for protecting that data because they're the ones with the contract with the client. So we ask the questions to the vendors because the vendors are always selling new software, right? Oh, we can do this, we can do that, blah, blah, blah. And then we ask them the question, how well are you protecting that data? Was your application built with a secure within the secure software development framework? Let me tell you, very, very few. There might have been one or two, Mitch. I can't remember, but it wasn't many people said, yeah, we got that covered. We did that. Usually it's like, oh, yeah, okay, yeah, okay. We think about that. We worry about that some, but so we got to go deeper. We got to have some answers on that. How do you prove that you did that? Oh boy, now we're in trouble. Now we're in deep trouble.
Put a pin in that and remind me if I forget when we get to the Microsoft section of this presentation. I want to tell a story about that.
Okay.
The challenge you've got, of course, is in the case of mortgages, the great example, it used to be that people ran that software that Ray was talking about that their customers upload documents to, and they get from, insurance companies and all those documents. That software used to run on servers in people's offices, and that has a whole bunch of vulnerabilities all by itself. Now, almost exclusively, that is done in software that runs in the cloud, that is hosted by a third party. So now you have a customer who's dependent on their mortgage lender, who is dependent on a software vendor, who, by the way, probably uses a fourth party. So you got this food chain, which is incredibly complex. And the contracts, if you are buying software and you're putting your data, or worse yet, your customer's data on that, the contracts don't handle that. In fact, who wrote the contract for the software license? Oh, right. It's the lawyers who work for the software vendor. You think they're going to go off and say, yeah, we're responsible for everything. Not a problem. If you have a problem, just let us know. We'll write you a check. That's not the way it works. In fact, one of the early things in almost all the software license agreements says, we don't even guarantee that this thing is suitable for whatever it is you want to use it for. You take your own responsibility for doing that. So producing well-secured software is not only a software that you produce, but your vendor produces on your behalf.
Let me give you another example. We have a client who is in the business of quantum computing. Now, they are developing software around, running quantum computers and an interface between other people who want to get access to their quantum computer processes. Okay, very high level stuff, very difficult, challenging stuff. I mean, leading edge. They want to obviously sell this to Department of Defense. We do a lot of work with the Department of Defense. They have their own requirements. This company, they got started, the quantum computing, they got started, a bunch of university professors, got all kinds of government grants to fund their research and become really good and really slick. They did, they've got good. Now then they spun off out of the university to go off and do this thing. But here they are now trying to go into DOD, and now they're looking back at what they've done and what they've created and how to adapt that securely, how to do that. Challenging, difficult to do, because it wasn't They weren't thinking about this up front. And I mean, nobody was thinking about this up front. Okay.
And let's think about that for a second, Ray, because it's a perfect example. Let's assume they did everything right and they built a great product, right? And they're selling this as a service. Do you think that the Chinese might be interested in whatever problems their customers are trying to solve with quantum computing? In fact, if you look at the China 2025 program, one of the technologies in that program is quantum computing. So we know that they and their customers are being targeted specifically. And it's not just the Chinese are just blatant about it. They don't care who knows. You know, you got the North Koreans, the Iranians, the Russians, you know, and oh yeah, don't forget about the friendlies, the French, Germans, the Israelis, you know, all of those guys.
Or your competitors, or the competitors to these guys. You don't think they're not sniffing out each other the best they can? And remember, the Chinese have 300,000 people in their cyber army. 300,000 people who go to work every day attacking various IT infrastructure around the world in an organized fashion. One of their biggest problems internally with the Chinese, from what we understand, is digesting and using all the shit their army is stealing. Okay, because you got terabytes of files of stuff they're bringing in. Well, someone's got to read it and understand it and figure out how do we and channel it over into the division of the Chinese economy who can do something with it. Okay.
Right.
And so, I mean, but it's a monstrous program that you don't want to become a victim of, do you?
Now you said terabytes, but it's probably petabytes or exabytes actually.
Okay, all right.
Yeah, it's probably a lot more than that. So moving forward here, after we've done all that, we still have to respond to vulnerabilities. These are vulnerabilities in software that you build and software that you buy, right? Whether that's patching, whether that is responding to an incident where data, you know, you had a data spill, and all of that needs to be done. And the biggest challenge that we have is, and I think I talk about this later, software bill of materials, is updating the components that went into the software that is the software that you are using. Again, whether it's software that you built or software that you bought.
Software bill of materials. There's a term that nobody understands. Nobody get. That's something Mitch brings to the table all the time. And kind of people go, huh? What is it? What is it? Oh, you mean we got to have an inventory of all items that go into our software application, all code sources that go into. You mean we got to do that? Yeah, that's what you got to do.
So while I'm talking here, Ray, if you'll look forward in the deck and see whether we talk about software bill of materials, if not, let me know and I'll just take a side journey and do that. So
no, we don't, Mitch. We have
okay.
Mitch. You've brought on, so you can bring that in
okay.
at any time.
Okay, good. So software
Since
bill
you happen to be a specialist on this and a rare one in this country, by the way.
Yeah, I've been working on this for about 4 years now. So what software bill of materials is, let's assume that you were a baker and you were baking brownies. In brownies, you have flour, you have sugar, you have something to make the dough rise. You have all these. You have spices. That is the bill of materials for the brownies that you're baking. Same thing for software. If you are running the XYZ software package, it doesn't make any difference what you're running, then it has a software bill of materials. What are all the different packages that went inside of it? You know, when we saw the Equifax breach, right, that was caused by the fact that they were running server on one of their machines, just one machine. Think about it. One of the largest attacks in the history of mankind, 150 million people compromised, was caused because they did not know that they were running Apache struts on this particular machine. That's a development framework. And so as a result of that, they didn't patch that machine. So not only do you need to know what are all the pieces that go into the brownies that you're baking, but you need to know where the brownies are being distributed. And you know, we see this in because people are more familiar with food than software. If you go into the food recall world, right? You know, they recall this piece of food because it's harmful. Who was selling it? What stores did it go? What states was it in? What time frame? You need to know all of that about your software. That is what software bill of materials is.
All
And
right, S-bomb. That's something else that all you executives out there should be embroidering on another pillow to remind you of that
and there is a
terminology.
NIST framework now that came out of NTIA, also a different part of the Department of Commerce. NIST is also part of the Department of Commerce. Spent 4 years building this SBOM framework, and now NIST has taken it over and standardized it and published it. So, absolutely important. So,
Just get now back to executives, just briefly, to remind me. So for executives and high net worth individuals, we have a program for protecting you and your families, but that's not the purpose of this training. Just want to throw it out there. Ping us. We can help you with that. Go ahead, Mitch.
So OWASP is talking about that third bullet of making sure your development process is good. So this eye chart, it talks about the OWASP process. They revise it every few years. This one shows what happened between 2017 and 2021. But these are the categories of vulnerabilities, whether it's access control or cryptography failure or some kind of injection attack or insecure design. These are the categories, and these are things that the development team needs to be working on, and every single member of the development team needs to be trained on things like, if you're using OWASP or BSA, whichever framework you're using for that, that they need to be, and this needs to be built in, baked in to the brownies that you're building, whether it's brownies that you're building in your own bakery or brownies that you're buying from a commercial bakery.
This is basic blocking and tackling right there. OWASP.
Okay, so let's go back. Now we're talking about Microsoft, and I'll go back to the point that I made a few minutes ago that I said stick a pin in it. So Microsoft was notorious years ago for having the buggiest software on the planet. It was horrible. And some of you who are in the IT world probably remember Steve Ballmer jumping up and down on the stage when Windows 7 was released and said, you know, this is the most secure software that we've ever released. And they still release 100 patches a month. Why is that? Because large parts of Windows and Office and Exchange and SQL and all the other Microsoft products were built, software bill of materials, using pieces that were built decades ago that haven't been touched in decades. And when Bill Gates back in 2003 did a total stand down of the company where they trained 70,000 people in secure software development lifecycle, and they've really done, I mean, it's hard, right? So I will give them credit. They have built an amazing set of practices, and you can see the link at the bottom of the slide there. It is all free. You can, this is for your developers. This is the nuts and bolts, the wrenches and the screwdrivers. This is not how do we do this from a governance standpoint, the other three bullets. This is just for bullet number 3, but it's an important bullet. They are giving away this stuff for free. And I really give them kudos, but they still have, you know, 100 patches a month because of all this old software that was built prior to 2003. And you think about that, this is now, you know, 2020 something, and they are still using software that was built. And even if they use a secure software development lifecycle process, it's not perfect. It's being done by humans. So it's a continuous iterative process, and that's an important thing. So this is a 12-step program, like other 12-step programs, and I'm not going to read the slides. You can read the slides for yourself. But this is a 12-step program that they have built and that they internally use. It is mandatory. You cannot release software without following this methodology inside of Microsoft. And they do, you know, for those of you who know from the software world, continuous integration, continuous deployment. They do continuous integration, and they do nightly builds. and they use those nightly builds inside of the company. And if you release some software and that breaks the nightly build, you're not going to get fired. I guess if you do it a number of times, you'll probably get fired, but you will certainly get a ration of crap from the rest of the teams inside the company because you broke the nightly build. And so that they have integrated this totally into their methodology. I can, name, a half a dozen companies who have really done that very effectively. And for medium-sized companies, less than, 10,000 developers, it doesn't exist. But you have to adapt this for you. You have to make it work, whether it means using static code analysis, number 9, or dynamic code analysis. All of those are nothing is free. Nothing can be done in 0 time. Penetration testing. We do penetration testing for applications. That means, is your application, are the security controls that you have put in the application, are they rigorously enforced, or can bad guys figure out how to get around them? Time and time again, the penetration testers just go off and say, this thing looks like Swiss cheese. Every now and then we'll find an application that has great security development practices and we don't break in. But, the standard model is, not so secure.
Now, if you're in management again,
you got to pay for it. You got to prove it. You got to allocate time. You got to question people. You got to do all those things as management.
All those things you got to make sure those are happening. And you can use, and we know that many company executives and company owners, you don't know diddly jack about this. Okay, we know that, but we can be your ally. We can be your advisor. You can say, hey, Mitch, here's where we stand on this.
What should we be doing about tools? Should we be doing static code analysis? What about penetration testing? And then we can ask your team, well, what are you doing?
That's right. And it's coming from you, and you're standing behind the question, and they will be getting it done. Now, they're not going to like, it's going to be painful. They're going to bring you problems. Here's one reason we can't do it. Here's another reason we can't. You're going to go, we got to do it. We've got no choice. What do we got to do? Well, we got to do this. And remember, you are slowly raising the bar on your application. You're not going to be perfect, but you're making it harder and harder and harder and requiring higher degree of skill to break in. So that on the opposition, on the people, the hackers, you're making them spend more money to break into your system. And when they break in, it's going to cost them more money and more time to move around and do the things they need to do, because they're going to be finding their doors are locked, things are blocked off, traps are being set, all kinds of stuff going on that makes it, and they might go, oh, the hell with this, let's go into somebody else that's doing nothing. That's the idea here, right? But you got to start someplace and make a commitment to it. And it's got to come from you at management. If it's not coming from you, it's not going to happen, baby.
Yeah, absolutely. And you need to be doing, a secure development framework review on an annual basis. Again, whether this is software that you're building or software that you're buying, everybody's business is based on software. And a lot of the software issues are not necessarily bad software design. They are people not implementing the configuration correctly. For example, much software comes with some kind of default password. We did a penetration test on a client a couple of years ago, and they have 40 offices, 40 some odd offices. Out of the 40 offices, we found 2 offices where their firewall still had the default password. 38 times they did it right, but twice they did it wrong. Okay, so let's look at this, and I'm not going to go into gory detail here because it's really going to be boring if I do that. But let's start with training. Most developers were trained in how to write software. Most systems engineers were designed in how to go off and implement the functionality that their customers ask for. Most program managers are trained in how to reduce cost. You didn't hear me say anything about security in any of those. And it's not one and done, right? And we don't want people being expert in this. We just want them to be knowledgeable. So here's a Microsoft book It's free. Another one of these books, and it's in your share. If you're a client of ours, we can share this book with you. It's free. It's like a, I don't know, 500-page book. You know, it's a great Bible for developers. You know, here for engineers, you know, system engineers, you know, here explains the security development life cycle. You know, Microsoft is giving away this stuff for free. Now these, you know, in fairness, right? They also sell it. If you want the printed one, you can buy the one. And if you buy the printed one, it comes with a CD and stuff. So I'm not saying that this is a replacement for buying these books. And these are all employees. Jim Alshin, who wrote the forward in this book, was an executive of Microsoft at the time. So, you know, they're providing us. But let's look at the SDQ+C framework that they came up with, which
As
is
a manager, excuse me, Mitch, as a manager, executive running the company, I know you're not going to read this book. You have no interest in it. You wouldn't understand it. It's not for you. But the technical people, now actually, they do like reading this kind of stuff. I mean, that might sound kind of crazy, but they actually enjoy it because they understand what's going on in there, and they're going, damn, yeah, okay, I'm getting better and better at what I do. They like, but you've got to tell them, you need to read this. I want you to read this. I'm going to pay you for 10 hours or 15 hours to read this thing. And if they get any tests in the back, take the whatever, get it down and read it and let me know you read it. So I know someone around here has read this thing and understands it. Boom. You're
and
in a different place.
And that really starts with the team leads. We have a client who the team lead really embraced this concept when we introduced this to them, I don't know, 5 years ago now. And he like took off with this. He integrated this into all of his team meetings, you know, and he like really believed that he understood the risks to the company as a result of not doing that. So the, you know, the leaders in the technical side, whether it's engineering, whether it's requirements, whether it's project management, and it may well be, you know, you're not going to read this book from cover to cover. You're going to go look at the chapters and say, oh, this is an interesting chapter. Let me read this chapter. This applies to me. So you don't have to sit there and read, you know, 500 pages.
Remember, Mitch, again, just one time, just mention the word risk. What are we talking about here? Helping you reduce risk to the company, risk to your livelihood, risk to everything you have built. Are you willing to accept the risk of insecure software that you guys are developing, or the risk to insecure software that your company is dependent upon using to survive? That's your call. It's your call. If you're willing to accept that risk, well, then away you go. You can turn off this training. If you're going, really can't accept that risk anymore, well, then please continue. Mitch?
But risk is not monolithic, right? So for example, you know, the first bullet there, secure by design, that we've talked about that, but let's talk about secure by default. So what you want to do is turn off the features that you're not using. You want to use that to reduce the attack surface, and you want to give people least permissions that they can do their job. Well, that is a situation where you need to go look at that and say, okay, do I need this feature? Is it a feature I'm going to use? Is it really some? You may remember early days of Windows, there was no Windows firewall. And then in whatever it was, I don't remember which version of Windows they introduced the firewall, it was off by default. That's a wonderful firewall. It's off by default. There's an expression we use in the tech world, the tyranny of the default. Another thing to embroider on a pillow. The tyranny of the default means that 99.99% of the people are not going to change the defaults. And so if something is by default, if you're developing software, or by default, if you're buying software, off or on, depending on which way the bad situation is, you know, you can't just assume that the defaults are correct. Finally, Microsoft, you know, in some version of Windows, and I think it may have been Windows 7, turned on the firewall by default. But then, because by that time they had already done a bunch of really bad practices, they had to make all these holes. If you go look at the Windows firewall, my opinion personally, it's about as useful as a screen door in a submarine. Think about that analogy. Not very useful, because they have poked all these holes in it so they didn't break things that they had already, bad practices that they had already instantiated. So Secure by default is important. Secure by deployment, okay? Do you provide, if you're buying software, does your customer give you guidance of, here are the best security practices that we know for how to use our software? You know, there's an attack going on right now on an open source database called MySQL. And what the white hat hackers, the good guy hackers, have found tens of thousands of MySQL servers exposed to the internet responding to queries. A really bad deployment practice. Almost never, and I would probably actually say never, should a SQL database be exposed to the internet directly. Really bad deployment practice. And your developers say, but we need that. Well, go back to your engineers and say, go fix that, change the design, because that's a really bad design. Because now you're counting on the security of that database, you know, from the person halfway around the world. I mean, that's the problem, right? When your computers, your servers, your network was inside your building, you were only worried about people who were in your city, right? They had to physically break into your office to steal your file cabinet full of papers. I know I'm dating myself, but and that's unfortunately not that long ago, maybe 10 years ago, literally. And as a result of that, you know, the attack surface was relatively small. Now everything is publicly exposed. It's sitting in the, and I'm not beating up these guys, the Azure cloud, the Microsoft cloud, the Google cloud, some private cloud, but it's publicly visible. Now, you know, some bad guy in Iran who just got berated by his boss for not working hard enough, you know, he or she is going to work 12 hours a day trying to break into your computer that's sitting in the cloud, and you don't even know that they're nearby. You know, at least when they broke into your office, when you came in the next morning, you saw the door was broken in. It was pretty obvious that something bad occurred the night before. And lastly is communications. You know, we've seen in some of the hacks that have gone on recently that the companies have done a really, really bad job of communicating with their community being their customers. So that would be either be your vendor's customers or your customers if you're the vendor. You know, and you got to be transparent. You got to tell people what happened. We saw this with an attack that just happened a couple of weeks ago, and you got to demand this from your vendors, and you got to provide it. This is management. This is not the IT guys. And I was listening to a video yesterday where a bunch of lawyers were talking about how now it's turned into this situation where when there's an event, you have a whole bunch of lawyers in the room who are telling the CEO what they can and can't do. And you may remember when Zoom had the problems they had all those lawyers, and the CEO of Zoom said, expletive deleted, I understand, thank you for your advice. I am going to go off and tell people that we are responsible for what happened and we're going to go fix it. And the lawyers, I'm sure, cringed when that happened. And I'm sure from a liability standpoint, it didn't make them happy. But from a customer standpoint, guess what? Zoom's still doing pretty damn good, you know, because people know that stuff happens. What they don't like is when you are covert and try to pretend that it didn't happen when everybody knows it did happen.
You mentioned clear policy at the end there, Mitch, correct? Clear policy, but just policy. Do you have a secure software development policy? You don't need to answer that now, but now, since you've been trained on it, you need one. There you go. Next.
Yep. So now next, you know, we were talking about this building software. Now we're talking about the requirements. The users don't care about the requirements in terms of how you construct that. They care that you have a tasty brownie. They don't care how hard it is for you to bake it. They don't care how expensive the ingredients are. They want a tasty brownie. So the engineers who are doing the defining of the requirements are the ones who need to be looking at, well, what are the security things? For example, I've never heard a user yet say, you know, we really need really robust security logging in the software that we're buying from you. They don't care about that. They care about, does it work? You know, if it's accounting software, does it keep my books? But when there's a problem, all of a sudden the logging becomes very important. And so that means the requirements need to include what legally you're required to have. Have you ever looked at your contracts and see what's in your contract? Are you actually complying with your contracts? You know, best practices. You know, if there is an incident and you can say, we are following best practices and here's how we document that we're following these best practices, well, then that really puts the other side's lawyers at a disadvantage, because, you know, everybody knows that nothing is perfect, but, you know, where you get in trouble is when they say, well, you weren't even trying very hard.
If you have cybersecurity insurance, you may have a question that will ask you if you're building applications.
Or buying applications. They ask for both now.
Or, okay, building or buying applications, correct. And it says, the application that you're building or the application that you're buying, was it developed following industry best practices, software development best practices? Okay, you can put down there, yes. Okay, now you get your cybersecurity insurance, but now there's a problem. Now there's an incident. Now there's a breach. The company comes back to you and say, okay, you answered this question, yes. Where's the documentation on that? How do you prove to us? Now, if you're able to pop right back, okay, here's OWASP right here. Here's the dates. Here's what we're doing on this. Here's the NIST software development framework checklist over here. Look what we've been doing. Oh, they're going, all right, check, you've done it right. If you don't have that ability, sorry, no insurance payout. That's on you as the company executive, because remember, I'm talking to you. That's on you. That's your problem.
and for software you're buying, there's a process which is directly related to this called vendor cyber risk management, which is taking all these things we're talking about and applying them to the vendors. Actually, I don't think we talked about this screen. So next section is defining metrics. You know, what are your quality metrics? You can't have a metric if you don't track it. You know, you got to figure out what metrics are going to be valuable. You know, threat modeling. What are the threats we're worried about? You know, if this software is used internally, it has no customer facing component, it has no public internet facing component, that's one set of threats I'm worried about. This is a really sad story, but nonetheless it happened. Recently, there was an attack at a gun range outside of Los Angeles, and they had a whole bunch of security cameras, very typical of those kind of installations. And a bad guy came in and killed a bunch of people and stole the video recorder. So it's great that they had all those cameras, but the threat was someone's going to come in and steal the tape recorder that's recording your cameras. Well, there's ways to mitigate that, but they hadn't considered that threat, and they still, unfortunately, have not found the guys who did that. You know, you want a book. Here's a book from Adam, great guy, super knowledgeable guy on threat modeling. You know, let me tell you,
a whole book on threat
modeling.
Tell you,
Adam is the guru on threat modeling. If you want to know, you know, the guy who is like the expert in the industry. Again, it used to be a Microsoft guy, he's not there anymore. Probably because he makes too much royalties off his book. He doesn't need to work. But you know, threat modeling, you know, great thing for at least some part of your team to understand, and probably parts of the book useful for every part of your team to understand. Okay, now let's talk about the requirements, right? You know, the user doesn't go off and say, hey, I want to have, you know, two-factor authentication, or I want the data to be encrypted at rest and in motion with FIPS 140-2 certified. They're not going to say that. That's a design requirement, and your engineers who are doing the design need to understand what those requirements are. And you have to be careful, right? Because that can sometimes backfire on you to make the software too hard to use. So, you know, there's a trade-off there, and with all risk, right? We're trying to, you know, the only secure computer is the one that you never powered on. What we're trying to do is minimize the risk. We're reducing the risk to an acceptable level. You know, what is reasonable given the risk that this system represents. God, many times we've seen this. People go off and build their own encryption, and the problem is encryption is hard to do. The reason why there is a federal standard for encryption security is that it is hard to do. And if you make bad choices, like a bad initialization vector, then you really don't have any protection. And people say, well, I don't know whether I should encrypt. The overhead of encryption nowadays is so low. If you have a question, just encrypt. So I think we really talk encrypting both at rest and in motion. People like websites. You have a HTTPS, which is under the covers something called TLS. That is encryption in motion. That is not encryption at rest. And now we're seeing more and more insurance companies that say, if you did not encrypt this at rest, then you don't, and it's stolen, you don't have any coverage. And like I said, this is the federal standard FIPS 140-2. Third-party components. This is where the software bill of materials, I did talk about this, where software bill of materials comes in. It doesn't matter whether it is commercial software or open source software. People have often said, and I just shake my head, that, well, open source software, it's secure because anybody can look at the source code. Yeah, well, I hate to give you the list of, well, we just saw earlier this year, Log4j. It's a Java logging library. It's open source. It's used by millions and millions of companies, literally. And it had like a really super major hole in it. So open source software, it has advantages. I'm not beating up open source software, but don't assume that because it's open source, it's secure, because it's not. And that's a package that has a lot of visibility to it. There's a lot of open source package that was written by one guy. He published it, and the code has never been looked at by anybody else, including the guy who published it, ever again. And if you use open source software, you need this accurate inventory, the software bill of materials, because how do you know whether that person or somebody else updated that component that you're using because there was a security problem in it? You got to understand your risk appetite and risk result and software bill of materials. And this is complicated. I don't expect anybody to be able to figure this out on their own for the first time, but we can certainly help you with all of this stuff.
Question that you ask, the question you ask is the executive, do we have an SBOM on this application? That's the only question you have to ask. What's an SBOM? Well, software bill of materials. Oh, and say, we need one. We need one of these. Oh, how do you do it? Well, okay, that's another question. But you ask the question and you get them to bring that thing back to you. And then you could have it. You could say, you could hand it over to Mitch. Mitch, does this look like an accurate SBOM to you for this kind of an application?
Does it have the right field? Does it have the right information?
Right fields and stuff on here. And Mitch will say, well, I don't see anything coming from GitHub in here, or whatever he's going to say, and but that's okay. You're covering your bases. You're managing the risk you are responsible for at that point.
Right. There was a very public breach back in 2018 at British Airways. And it had compromised about 400,000 people. What happened was, in the supply chain, they were using a third-party product, MagicCard, and a bad guy had gone off and inserted 22 lines of code. That's all it took. And then when British Airways integrated that into their website, those 22 lines of code came with it, and it made the entire website vulnerable. So this is not something that necessarily takes massive effort on the part of the hackers. 22 lines of code, not a massive effort. Apache struts, I just talked about that earlier. That's the one that caused the Equifax breach. Now, in that particular case, it gets really bad, right? So this is where you have those 4 bullets we talked about, where the development part of it is only one part of it, right? the Department of Homeland Security warned Equifax about this particular attack vector 2 months before the attack happened. Equifax patched Apache on the servers that they knew about, but they didn't have a software bill of material, at least not an accurate one. And oh yeah, by the way, Apache Struts is used, you've probably heard of VMware. VMware uses Apache Struts. So it's not just software that you develop or you host. It's your vendors that do that. The fact that they did not patch this one server is the thing that allowed one of, if not the largest breaches in the world ever to occur. OpenSSL, another piece of open source software. Heartbleed was a well-known attack. And OpenSSL is used by millions and millions of websites. It's the go-to product for people that are running Linux servers, web servers. And it has bug after bug after bug. Heartbleed is just one of the big ones. But open source does not mean bulletproof. Open source means that you've outsourced the problem to somebody else. Approved tools, that's pretty straightforward. Make sure that you're using the latest version of the tool. Well, we didn't buy maintenance. Well, there's a reason why they update the software. It's because there's a problem. And many times the tools have security features. Are you using those security features? Here's again, Microsoft. I mean, they have really, really gone out of their way. And I love to beat up Microsoft. This is one where I just can't do it. They've really gone out of their way. They've made all these tools available for free for people who are developing using Microsoft tools. And even if you're not using Microsoft tools, some of this stuff is still applicable. Threat modeling tools and code analysis tools for C++, stuff like that. Here's some more tools. There are lots and lots of tools, but you got to go do this. What do you do? Another part of Microsoft security engineering website. How do I look at what the attack surface is for the tool? How do I make sure that I'm not using bad function calls that are inherently insecure? I mean, lots and lots of tools that exist. So static code analysis is something which I really support. It's not, there are some open source ones, but for the most part, they're not free. There are some pretty cost-effective ones though. It's low effort if done right because you actually integrate it into the build process. The key issue with static code analysis is that initially it probably generates a bunch of false positives, and you got to tune it to get rid of the false positives. But it's going to get rid of the out of bounds arrays and all those kind of things that people don't necessarily, or maybe a type transfer between two incompatible data structure types. They're going to catch that sort of stuff. But you want to do this automatically, and you want to integrate it directly into your build process. Dynamic code analysis is basically a lightweight version of penetration testing done at runtime in real time while the software is running. And it can only detect vulnerabilities that are visible while the application is running. Fuzzing is a very popular example of that, but again, there are tools and frameworks to go do that. More people do static code analysis, dynamic code analysis. Dynamic code analysis is harder and typically more expensive. Where you want this static code analysis to be done is when the developer checks in the code. Then you have penetration testing, and we talk about, with our clients, we talk about application penetration testing versus network penetration testing. Those are two different bears. The network penetration testing is the infrastructure secure? Application penetration testing can be done either as an unauthenticated user or as an authenticated user. You need a very special skill set, and we have folks like this that are a combination of a hacker and a developer. And in fairness, it's expensive, but so is getting hacked. So you got to decide where your risk thing is. And typically what you want to do, what the insurance companies want you to do if you're developing software, is every time you go off and release a major version of your software, you should do an updated penetration test. You know, if you're not developing your own applications, you know, probably application penetration tests are not on your radar, but you should be asking your vendor, well, tell me about how often you do application penetration tests, and how do you manage the results of that?
Can you send me some documentation on how you're doing that?
Yeah. Incident response, you know, we sell an entire incident response program. And that's what everybody wants. You know, now with the new laws, you literally have a couple of days. If you're in the one of the critical infrastructure environments in India, like you're an IT provider that's considered critical, you have 6 hours to report the incident. You know, the DoD, 72 hours. The federal government, and under this new executive order, in fact, I'm sorry, under the new spending bill that went into effect last December, I guess it was, you have 96 hours. If you pay a ransom, you have 24 hours. So you better have an incident response program. This includes both incidents for your products, incidents for your networks, incidents for customer data. And you know, the window used to be 30, 60, 90 days, and the lawyers loved that because they got to munch around on that. And well, you know, depends on what your definition of is, to quote a famous politician. And you know, no, you know, you now, and we're seeing these numbers are definitely going to continue to go down. This is not something that is a flash in the pan is going to go away. So it's got to be methodical. It's got to be documented. It's got to have all the parties involved. And unfortunately, the lawyers are going to be deeply involved in this. If you have cyber insurance, your cyber insurance company is going to want to have a say in this because they have picked vendors, in part the vendors that they have vetted, but unfortunately in part is vendors who are the lowest cost vendors. But the insurance company is not working for you. The insurance company is working for them. And so you want somebody on your side who is vetting what the insurance company is telling you got to do so that you can go push back. Obviously, we can do that for you. You know, if the insurance company says, nah, you don't need to do this. That's, you know, bull, bleep, you know, yeah, you do. Yeah. And maybe you don't need to do it, but more than likely, you know, it's just them trying to save money. You know, for a couple of years, the insurance companies were paying ransoms because it was cheaper to pay the ransom than to have you actually go rebuild your system. Well, now with new laws and stuff and disclosures and that sort of thing, and with the ransoms going dramatically up from where they were, it's no longer so cheap. And if you pay the ransom, you don't know whether the bad guys are really out of your network or not. So from that perspective, you really want somebody on your side, but you got to have a really well-defined and tested and trained. You know, Ray does routine training with IR teams, you know, on a regular basis. We do create these desktop scenarios, and we're good at throwing monkey wrenches into those scenarios. Well, you know, we're doing this incident, and then guess what happened? So, anything you want to add to that, Ray?
No, it's another subject matter, but life is complicated and we can make it that way for sure. But it's okay. It's all part of, you know, getting in. But incident response with respect to this subject category is important.
Because, right, let's say you bought software or you built software and something occurred, there was a spill. Well, the first thing you got to figure out is how that happened, you know, and that's part of your incident response. And if it's your software, you better have the right log files to be able to figure out, well, you know, how that occurred. Without log files, it's really, really difficult to go off and do robust forensics. And the incident response team, like I said, mostly it's going to have a lot of lawyers. Sorry. I mean, in the Zoom case we were just talking about, you know, there were lawyers for the company, there were lawyers for the board, there were lawyers for people on the board who disagreed with the majority of the board, there were lawyers for the CEO. I mean, there were a lot of lawyers in that conversation after that, and that's public now, so it's not, you know, nothing.
On that list, I would of course put executive management at the top, because it's on you. It is on you what the effectiveness of the incident response and any repercussions of a poor incident response and whatever that happens to the company.
Remember,
Because,
all these guys are advisors.
yeah,
You as the CEO have to make the hard decisions.
that's it. It's on you. And you don't even, and you're going to run that incident very quickly. Yeah, that incident's going to be reported. And okay, let's get out our incident response program, assuming you've got one. Let's get it out. We've rehearsed it, assuming you have. And let's start down the list. Everyone's going to be looking to you to make those calls. And when we do those tabletops, we always throw things in there where everyone's head pivots over to the executive management. What should we do now? Should we call in this person now? Should we do this now? Is it time? Has the situation gotten to the point where we need to escalate? What do we do now? What do we do now? They're looking for someone to make a decision about how much risk is the company willing to take at this moment in time. Are we going to,
yeah. Another short story. Everybody remembers the Sony breach after North Korea got mad at them for releasing the movie that they released that made fun of their fearless leader. About 6 months prior to that, the Sands entertainment chain, the casino and hotel and stuff, got hit by a very similar attack from the same people for the same reason, because the guy who at that time, he's passed away now, Sheldon Adelson, owns the Sands, was very pro-Israel, which they didn't like. The outcome was dramatically different. What was the difference? There was only, in my opinion, one primary difference. And the difference was Sony had gone off and done a threat analysis about 5 years before the attack and never bothered to update it. The Sands had a super robust, well-trained incident response team. And that included the incident response team made the decision and was authorized to make the decision to pull the entire entertainment complex, the entire mega corporation, off the internet. They did not need to ask anybody. They also had the approval. The pit bosses in the casinos kind of run the world, rule the world. They had the authority. Literally, they had IT team members running through casinos, which probably made the physical security guys scared to death, unplugging pit bosses' computers to make sure that they didn't get compromised. They could do that on their own because Adelson had authorized them. He had found the right guys. He had trained them. He understood the risks, and he made the decision. You guys are the experts. You tell me what we need to do to protect our rear end, or some other word.
Adelson was smart enough to know that this could bring down his company. He got that. And he said, what do I have to do?
He was not a tech genius by any stretch of the imagination.
No. He's a good business person. He's a smart business person who understood his enterprise and what drove it and what made it work. He got that part and he did those things. And what a beautiful response.
I mean, you never hear about the Sands attack except as a textbook response to an incident. That's where you hear about the Sands. Now, did some of their computers get caught? Absolutely. Were they down like Sony for 4 months? Did they have to get the SEC to give them a waiver not to file their financials with the SEC because they didn't have an accounting system that worked? No, they didn't have to do any of that because they had planned for it.
Before we
And
go to this, Mitch, there's one other topic that we didn't include on this slide deck, but as we're talking here, I want to throw in here. So I'm talking again to the executives, the decision makers. Okay, you're sitting there. Here's a scenario. Yeah, my company is making software applications. We've been making them for a while. We've got 4 or 5 applications or whatever, and we got to sell the products coming off it and whatnot. And currently, we're spending all this money to build these applications, and everything that I'm seeing in this presentation is going to add substantially to the price of getting this done. It's going to be more expensive. There's a lot more to it. And I go, cannot be denied. That is true. But then
what
we
is
go back.
substantially, Ray? In fairness, it might be 10%.
Maybe it
It's
just
not
depends, but it's
90%
going to be
more.
more. It's going to be more when you do all the code scanning and you train the people and you do the stuff. Yeah.
Absolutely.
So it's two kind of a things here. Are you going to do this before you have a problem, or are you going to do it after you have a problem? If you do it before you have a problem, let's say you have an incremental increase that you have to gag down now. Gag it down, get it down. Now you've done it. If you do it afterwards, oh, Katie, bar the door. It's going to be a totally different thing. But then your hair will be on fire and you'll be signing checks left and right because you got to do it because the company's going to go under if you don't do it. And the price will be 10, 20 times more than if you did it up front and did it smart like Adelson did at the Sands. That's good. That's one cost scenario. Let's take another one. You're building a company. You've built a company. It's got applications in it that you're dependent on, that you're delivering services and whatnot. You're out in the marketplace going to sell this company to someone rolling it up, private equity firm or whatever you're going to do in there. Okay. And so me as an investor, let's just say, or Adelson or anyone comes along and they look at your situation. You've been building your company for 10 years and they're looking to acquire companies, and they look at your company. You're really a good player in the marketplace, and they're looking at a competing company, a really good player in the marketplace. One company is able to say, hey, take a look at how we protected all of our intellectual property assets. Hey, take a look at how we've been protecting the development of our code for, these many years. Hey, look at how seriously we've taken that. And when we are going to say, take a look at the competitor that you're looking at buying, okay? We are valuing our company. The valuation of our company is 4 times the value of that company. Why? Because our intellectual property has been properly protected and we can document it. If they can't document at the level that we are, kick them to the curb. You don't want any part of dealing with them because you're going to have to go in later and spend an awful lot of money to fix that stuff. That's why we're more expensive, but that's why we say our valuation is greater. And because so much of IT infrastructure, so all companies now are operating on top of IT infrastructure, we worked with the National Association of Certified Value Analysts. We approached them. We told them, in your formulas for business valuations, are you computing in the protection of the IT intellectual property protection? Are you? No, we're not. Well, don't you think the time has come to do that? Yes. Okay. So they asked us to write an article on it, a generic piece, which they published, and they've built it into their standards. Valuations now are predicated to some degree upon how well you've protected this information. So cost, question mark, is it worth the cost now and at the exit? I'll let you answer that question. But you, as the executive, put it in there. Stitch that on another pillow. Valuation, question mark.
So 2 things about that, Ray. If you want a copy of that article, contact us. We can give you a copy of the article. Second thing, people probably remember in 2019, the foreign currency exchange service Travelex got hit by ransomware. And of course, the first thing the spin doctor said, oh, this is not going to have any impact on our business operations. It's just a blip, you know. And 30 days later, they were still down. All of the banks that use Travelex as a service shifted to one of their competitors. And ultimately, in about 90 days, as I recall, Travelex filed for bankruptcy. So cost, okay. What is the cost if you do it now versus what is the cost if you do it later? And, you know, Travelex was an example of a company that had said, well, you know, it's too expensive to do it now, we'll do it later. Didn't kind of work out so well for them. So food for thought. And they're hardly unique in that regard. We've seen a number of companies that have filed for bankruptcy, especially smaller companies, because, you know, when, for example, when the Home Depot breach or the Target breach happened, right? You know, and these guys had to go off and spend $50 million, $100 million. Like, you know, kind of, let me look in the couch cushion, see if I can find, you know, a few tens of millions of dollars. Most companies, that's not the case. You know, if they have to come up with $5-10 million, $1 million, that's a real problem. That's a threat to the company's existence. So pay me now, pay me later, like Ray said, you know, it's way cheaper to pay me now. Anything else you want to add to this, Ray? We're about an hour and 15 into this.
If you're an executive and you made it through all of this and listen to this, I'll wager you're a changed person. Thank you very much for taking the time to learn this. It will be of benefit to your endeavors, I do believe.
And obviously, if you have questions, please reach out to us, because, you know, there's a lot of information we just threw at you, and we don't expect you to be an expert after listening to, you know, a 75-minute presentation. We expect you to be more understanding of what the problem is and how big the problem is. So, thank you.